So when it comes to coding guidelines or coding style, Python implicitly enforces you that anyway. Like other languages, you can simply write a code without any indentation. Nothing is going to break other than people getting mad at you if you don't indent things properly, right? But Python's way of writing functions or loops or conditions is actually based on indentation. So that means there is a level of clarity and semblance when you look at the Python code, right? And in addition to that, there is also a standard that governs how it's a recommendation how you can change, how you can adhere to coding style. So which is if you follow it is good, right? So something that you might want to look at is PEP 8, and I believe the other one is called PEP 20. It is about writing documentation. Okay, at least PEP 8 you should start with, try to find out what are the recommendations and stick to those, right? So they have information about how many spaces you can have around operators and how many empty lines you can have between two blocks of logical unit of code and all those things, right? So I have this simple, it's not even a program, right? It's only a data structure. So I am just putting it as a module. So this is one of the data structure that has been used in the RTO finds case study that we have seen, that we generated several files, right? So this is something I put it is similar to the JSON, right? So I created this data and then I formatted in JSON. And since the data syntax is pretty much similar, I simply just copy pasted this data, which I got it from internet. Okay. So what we are going to do is we are just going to run the validation, whether it is a valid data or not. Okay. So PEP 8 state info file. Okay. Or you can write PyCode style also. So this might produce sometimes, depends on the number of lines. There might be a lot of data, a lot of reports. So I'm just going to pass it to the less command so that I can view one page at a time, right? Okay, so it appears like I have the same error pretty much on each and every line, right? So that's there. So let's see what it says. It has 184 lines, and mostly it says extraneous. Okay, so that's some. It says like you can use PyCode style instead of PEP 8. Okay, but I do have 184 errors. Okay, so now, okay, so what is this error? W191, right? So there are a couple of options I have. I can do like quiet, right? And then statistics. So that's something that I can use to see what do we have. Okay, so it's annoying. It still says that code style. So let me see whether this helps remove the error message, right? Okay, that's great. So I have 184 messages. So what this quiet and statistics does is it suppresses the actual error message, and it simply tells you how many times each error or warning occurs. So if it says W191, it's the warning 191 that says indentation contain tabs, right? So one of the recommendations in Python is use spaces instead of tabs. Okay, so that's fine. Let's say I am okay with this, right? So what I can say is, I can say ignore W191, right? So now it is giving me another thing because the indentation check is not being done. Okay. So now what I'm going to do is I'm just going to run it with PyCode style, which is pretty much similar. Okay. So if you have it, so you can do the same thing. If you look at it, only the error message, the warning message is not produced, right? I can do the same thing with statistics. Okay, so it produces the same results, right? Now what I'm going to do is, so if you want to talk about a lot about this, then we need to talk about what are these error messages and stuff like that. Okay, so what I have just given you is the two commands that you can take it forward and then write code that are compliant with PEP8, and then further the prerequisite is you to read the PEP8 document, right? And if you're fine with that, it's fine. It's a request someone asked me, so and since I have done that in the past, I just thought I'll just throw it in, right? So the second thing is, let's say I'm just going to take a copy of this. So I'll just say copy stateinfo.py and then stateinfo.py.org. Okay. What I'm going to do is I'm just going to run black, which is another command which I have installed. When I say black is a module, some of these Python modules can be run as a command as well. Same thing with faker also, right? So I'm just going to say stateinfo.py. So be aware that, okay, if you're running the black command, if your Python has syntax error, then the command may not work properly. Okay, if it is running and then if you want to make sure that it is converted into PEP8 compliant, you can run this, right? So I'm just running this. It says reformatted stateinfo.py, all done. So you have cakes and stars, and so you got that, right? So now let's first quickly look at what actually happened, right? So I'm just going to get the word count. My original file was 186 line long, and then it has been converted into 39 lines. Okay, so let's see what it has done. Right? So it has reformatted, no tabs, and then after the key, I normally tend to put a space between the key and the colon. So it removed all those things. So it made it very succinct, right? And then if I look at this, this is my original thing. So that's a 186. Okay, so black can do this. Okay, so here the catch is, please make sure that you take a backup, right? In case if you don't like the way black has formatted things, or you don't accidentally it screwed things up, you may not want to blame somebody else. Always take a backup, right? Let's run PyCode style on another module that called right. So there is 48 lines, and then here we have a lot of so I have some of these, and what we can do is I can say like max line length. This module checks for 17 characters. Let me say I am just putting 95 or 97 characters because I have a broader screen. Right now, that the error 10 times occurred, like E501 is become 3 times because there are like 3 that is 106 byte line wrong. So whatever was 81 bytes and less than 79 has gone. So now it is only catching the 97 bytes. So you can tweak what errors you want to ignore. Okay, it's the same thing that you can do it with the black also. So now let me copy. And then I am going to run black. Right. So now let's see what it has done. Okay, so my original thing is 180 byte long. Now it has been changed to 215. So now Python, the black module actually added some thing like maybe blank line and things like that, right? So let me run pycode style with create py and let's see what happens. Okay, it still does the 79 characters thing. But if you look at it earlier, there were almost 186 errors. Now it is manageable, right? So let's look at the. Okay, I don't know what actually it did. So it might have made those multiple lines into smaller ones, right? And then this the rec has become a very formatted list. So I just put it in one line. And if you look at it, so this one, so instead of like more than 79 lines, so it has formatted a bit. Okay, so it did few things, right? So if I look at this add argument, so this is the original thing, and some of these are very big, right? So it has done some conversion. Okay. So another helpful utility, even as a beginner, if you want to create, very robust code, very professional looking. In addition to adding documentation, doc strings, and other things, you can always do a check on Pepe, make some changes, and you can also identify some of the errors you can live by as a person or as a team, so that you can always do this validation when you do some unit testing in case, if you're going to work on Python projects. Okay. So what we are going to do is, one is our custom logic, right? And the second thing is just load this file into a database and then pull the data, right? And the third thing is using a data analytics package like Numpy and Pandas. Okay. And I just want you to give a disclaimer at the very beginning. These samples are not, extraordinary ones, in the sense like I was only trying to demonstrate what is possible, especially around the Pandas module. There are other methods. Whatever I have done, it might take more, it might create more temporary data structures, so it may not be memory efficient. But the idea is to give you an introduction about using these things, how the line of code changes, and then how it can be very easy for you, right? You don't have to analyze GBs or terabytes or petabytes of data, even if you are a manual tester, right? So there is some sort of counting that is being done. If you want to know what is the expected count and then what is the actual count, so you can take the source and then do some quick aggregation like count, and then you can look at it as well. So when you hear Pandas being associated with data science and machine learning or whatever it is, just be aware. Okay, so maybe using this model with 1,000 record data set might be like taking a machine gun to kill mosquitoes, but still, right? You have a lot of bullets and you can still go ahead and kill the mosquitoes with machine gun. Not a problem, right? So first, let's look at what the case study is all about. And in this, like I have added code so that like you have the HTML in one place. You can take the code and run it locally as well, right? So there is a brief coverage of what it is. So we are going to write 3 different ways, like I said. So our own logic using SQL queries and then using Pandas. And the data set I am using is a CSV file, which contains 15 fields: district code, school code, student ID, last name, first name, gender, date of birth, 5 different subjects, their scores, a performance category or a performance level or grade, whatever you want. It's a string that says how the student performed. So there are like 6 or 7 different categories. There is also a do not report, which is to demonstrate how you can filter out data, which I have not found a very good way to do it in Pandas though. There is ways, but I couldn't, right? So for exclusion rules is exclude all records with do not flag set to white. So this do not flag is something that administration can set if the student cheated or they want to release the report. Okay. So okay, where is that sample data? Yeah, I'm not sure. Okay, I don't have a sample data here apparently. So let's see whether we can remedy this, right? Not this. Okay. So head this LC scores. Let's see. Right. So I have the state code, sorry, the district code, the school code, and then the student code and some names, some values. So that's pass, redo, proficient. So these are some of the values, right? So that being said, so this is something that you can use. So you can copy paste. It is all self-contained. So this methods create the random data for you. So I have, I have run this. So it has created around 63,000. 14 records, so you can adjust the counts, min count, minimum number of schools and maximum number of schools, or minimum number of students per school and maximum number of, so you can create lakhs or even crores of records if you want, right? So depends on how you want to go. So first thing is the CSV module and SQL, we will see it quickly. Then we will go to Pandas. We will quickly look at what Pandas is, and then we will look at the solution in the Pandas, right? So we import the CSV module, and then we get the file name, and I declare 2 variables, add state stats and DNR stats. So we are just trying to capture some information about the DNR. So even though it is not our requirement, right? And then I have my district codes with the district name as a dictionary. This is something I can put it as a separate file and then download it as well. Okay, but again, this is a self-contained documentation, so I am just repeating this. So here what we are doing is we open the file, we create a reader instance so that the parsing by comma can happen automatically. So we read each row. So in that we need only 3 elements, 3 fields out of this 15 fields that is available. My first field, which is the district code, my last but one field, which is the performance, which is a DNR flag, and the last but 2 is the performance level or performance category. So this file doesn't have a header explicitly. Otherwise, I might have used the dict reader. So here we kind of hard coded, which is not a good idea. You might want to think about other options. Okay, but here we simply just read one record at a time, get only the 3 fields that we need. If the DNR field is Y, I am just gathering the DNR statistics by district code. So every district, how many people were marked as do not report? It's something that we can check which district has a lot of cheating or something happened, right? And then what we do is, if a particular district code statistics is already not gathered, so we are just simply initializing the district add state stats statistics dictionary with district code as a key, and then an empty dictionary as a value, because we need count by each of this proficiency level, right? And if the DNR status is not Y, since we already created a entry for dictionary, we simply put the performance level, and then if you remember, we have the get method that can look for a performance level. If it is available, it can give you the value. Otherwise, it will give you a value of default value. It is simply the way to assign one or increment with the existing values, right? So we keep track of every performance category within each district separately. Okay, so this logic, 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, around 18 lines is our core logic, right? So this may not be a lot of code if you compare with the other two solutions, but let's think about, we want to put more information, right? So we not only want to get this categories, like maybe we want to get information about in this district, male, what is the distribution of each performance category, female, what is the distribution of each performance category, right? Maybe there is another flag in that variable in the file called rural or urban. So we might want to figure out how the students perform in rural areas with respect to urban areas. Maybe then you will want to get the statistics by district, by the category of the town, or a place where the school is, and then each performance level. Or maybe you want to get rural, male, rural, female. So it goes like 3-4 levels of aggregation or statistics, right? Then this code is going to get really ugly. Okay, so we got the count, and I have the valid status is hard coded because I want this to happen in this order, and I have this 3, 7, 8 lines that takes the ag stats and then it displays. Okay, so it just goes through each and every district, and since we have only the district code in the file, so we look up from this particular district info and get the name, and then we will get the value for each element, right? So like each categories, right? So what happened to Chennai? Oh, this is I didn't add Chennai, I guess, apparently. Right, so Arilur, so we have 17 people who are absent, nobody failed, and that is a problem in my logic. So some people have to redo, and then some of the subjects, and then there is pass, average performance, proficient performance, advanced level, so very top rating. So if you look at it, the distribution is kind of even because I just made like 5% absent, 5% absent, 5% extraordinary, and things like that. The coding is done this way. So this is not a very good way to plot because every district is going to look at the same way. But I have a report, probably like some 40 line of logic. I have the report. So this is CSV. So here what we use the dict reader. Sorry, not dict reader. We use the reader method. Then we use the dictionary, especially the get method to calculate the counts. So we kept track of the data using a complex data structure, a dictionary of dictionaries that contains count. And then finally, we flatten this data structure, again using the get method and then a nested for loop and some static list and some header and those kind of things, right? So you have so pretty much a one-page report, which probably we can print it in landscape, right? So this is a custom logic, which may be okay if you do a very simple aggregation. Okay, the more complexity you bring in, like exclusion criteria and several levels of categories, right? The one I talked about is very complex, right? So you have district, within district you want to find out rural and urban, and then within that you want to find male and female, and then within that you want to find the count for each and every category. So you have a 4 level of nested keys, and then so you have several counts, right? So when you go to that level, so this coding will get really out of hands, unless otherwise you go with a functional approach where you create small functions and then you call these functions to orchestrate. Okay, not a bad idea. The advantages of this logic is, let's say you want to split the files and do some parallel processing using threads, right? So you could do that, right? So you could make use of lambda, filter, map, reduce, and statistics and those kind of things. We can still write a robust module which simply uses whatever is available. No extra data structures like uploading into tables. I'm not discounting this as a bad method. It's just that, like, if you want to use this, so you really want to make small chunks of code and then use it to orchestrate the thing, right? So this is still a good one, right? The second thing, we use a SQLite database, which is there. So I have TNSSLC scores.db database that is being created every time. So we destroy and we create so that I can run it many times. The district information is reappearing. So here what we are doing is, so we use the OS path exist method to determine whether the database file is already there. If it is there, we just remove it so that we don't get an error when you create a file or when you create a table or when you load data, throwing some errors, right? So yesterday we talked about this SQLite module, right? So the SQLite is a database handling module, and any database will follow some of the same structure. So first of all, you need to know about some information about the DBMS, right? So since SQLite is simple file based, all you need to know is where the file is. So if it is like MySQL or Oracle, you need to know the host name or the server name, user ID, password, and then probably optional information like, timeout option, connection timeout, and all those things, right? So we do a connect first. So once the connection is successful, then you can prepare the SQL statement, and then you can execute the SQL statement, right? So if it is like insert or update or delete, this is all you need. But if there is a select, the select can return multiple rows. So you need to create a cursor and then iterate. So the select query result will be like a reading from a file. You simply iterate, right? So that's the logic. So here we connect to the database using the connect method, passing the database parameter, and then I have a query, right? So in case if you worked on databases already, you know what this is. So this is a DDL, or a data definition language. This is a sub language of SQL query, structured query language. So a create statement to create tables. So I have 14 of those fields marked. So we are going to load everything. I'm just creating a table to load it into the database. Okay. And then I'm going to insert. So here again, so this is what we call it as a prepare, right? So I told you, like, you can dynamically construct the insert query after reading each record. But the way we do is, we will put a placeholder as question mark, and then we will pass the values. So if you have 14 question marks, so you are going to pass a list or a tuple with 14 values, so that the values will be inserted. Okay, there are different ways to do this, but once the connection is done, the table is created, we are going to insert. Okay, so now we open the file and then we read it. We remove the last entry, which is the end of record character, which is we no longer need. So we pass the query and then the row that we got, which is a list of fields, to the execution, and then we keep track of the counter. Okay, so now this might be an overkill. Okay, because there are methods that are available. You can load a file into the database directly, but this is something that is suited as well. So now we have the data loaded in the SQLite database, and then the table name is called scores. Okay, so now what we are going to do is, we are going to do the analysis, right? So what we need, so we need the count of performance level for each district, right? So in SQL, there is a set of function, we call it aggregate function. So there are 5 of them: min, max, count, average, and sum. Not sum, min, max, count. Yeah, min, max, count, average, and sum, which are the very basic aggregation functions that are around the block for quite a long time. Now we have a lot of other functions, right? So we use the select query, and then we also use the aggregate function, and then we use a concept called group by. Group by is like telling these fields are my key, and around this key I want to aggregate, right? So it is like a pivot table, in case if you know Excel, right? So basically the query, what it says is, it is very English like, right? Select district code and performance level and the count. A combination of district code and performance level and the corresponding count. Okay, very straightforward. 3 fields you will get from the scores table, where the do not report flag not equal to y, because we don't want the do not report candidates. Group by district code and performance level. So you need to give these 2 things in the select as well. So whatever you give in the select, which is not aggregate function, that will come in the group by in the same order. Okay, so again, this is not a database class. So if you want to do perform similar aggregations like this, so this is the sample query, right? So I have another query. Here there are no parameters, so we have set it. And then, so this is going to give me multiple values. So what I'm doing is, I'm creating a cursor, and then I'm using the cursor to execute so that I can read one at a time. So again, the agstats variable is declared, and I am just going to iterate the query result 1 row at a time. So district code, performance level, and count. These are the 3 values. So this concept is called tuple unpacking. Okay, so you assign a sequence to a list of variables, and then one element each will get assigned. Okay, very helpful. And then this code we already saw, right? So this is same, but just that like it avoided all this unpacking and everything, and then writing your own one part of aggregation and then one part. So we directly go for something, a very simple way to keep the values, right? So we are not calculating, but we are only storing a list into a dictionary, right? Unlike here, so we have all this checks and conditions and then everything, right? So, and then we use the same logic here to create the report. So 17 absent, 187, 651, 70, 187, 651, 362, and 98, and so on. Okay, so this is all pretty much self-explanatory. And now let's go to the third part, which is an exciting one, using the Pandas package, right? So any questions at this point?
Yes, MK.
Yeah.
So as we can see, like we can process the file into a report using Python code as well as using the SQLite3 code.
Right.
So say suppose we have 10 million records or 100 million records. So can we assume that the Python code will run faster than the SQL code in this case to generate the same sort of report?
See, there is always going to be performance degradation when the volume increases, right? Again, it depends on the hardware infrastructure.
Right.
But yeah, it is generally assumed. So if you have, so this is, I'm only talking with respect to this example, right? So the data you're storing in memory, the count is not very high, right? Like it's only 38 districts, and then so you have 6 categories maximum. So you have probably around 300 keys combination, right? So writing our own logic might be much more performance give performance boost compared to a SQLite, and especially when you talk about a billion or 10, 15, 20 million, SQLite might not scale up, but there are other databases that you can use, right? So having said that, so again, it all depends on the complexity of what you want to do on your own, right? Because the database provides certain capabilities. If you want to make use of it, then our own logic running in 1 hour and then a database operation running in like 1 hour 10 minutes or 1 hour 20 minutes may not be an issue, because the database management system provides certain things like consistency and other things, which we might have to do a lot, especially when our code gets complicated. On simple cases, definitely file-based processing would work faster than database based processing, provided you are not loading a lot of data in memory, in the sense in the RAM, right? And if you can utilize things like multi-threading and other sort of optimization in your, not optimization, coding techniques, so you might be able to get a better performance using your own files, right? More code from your end, but it might be faster in most of the cases.
Oh,
that answers your question?
Yes, thank you.
Okay, so even though we are not going to use Numpy a lot, or we don't even use Numpy in this, okay, but Numpy and Pandas are always discussed together. So we are going to look at the two packages very quickly, some of the features, and then we will get into the solution by Pandas. Okay, so Numpy or numeric pi is a module that you can install, or if you install Anaconda, it will come as a package, as a part of the package. Is a support for numeric multi-dimensional data, right? It is a very optimized module to deal with numbers, right? So it also provides capabilities like, let's say you add two numbers, right? Two lists in a normal sense, it will get concatenated. But if you have a list of 3 elements, that is a NumPy array. If you add those two NumPy arrays, it will add individual elements and then give you a like a new list with added value, like matrix addition and multiplications, if you remember from your old college days, from linear algebra and matrix process, right? So it provides a lot of mathematical capabilities at the dimensional level, right? And see, a lot of this machine learning, like classification problems and other things, uses linear algebra concepts, right? Like a lot of matrices and things like that. Fourier transformation, Laplace transformation, random number generation, simulating uniform values with, like if I have a minimum value of 10 and then maximum value of 10,000, I want to generate 5,000 data points between these values, which should be having a uniform distance, something like that, right? So all these things that we will use in simulation, that in analysis means, like if it is not a classification problem, you deal with numbers and then you come up with some averages and so on, right? Like the plotting. And so where there is a lot of numerical processing is needed, NumPy will handle it. And NumPy is integrated, or in the sense, NumPy is internally used by Pandas. So that means, like whenever you use Pandas, chances are that you have to import the NumPy already. So whenever you create a particular array or a data store using NumPy, it is called an ND array, right? ND array means n-dimensional array. So you can create 3-dimensional, 2-dimensional, 4-dimensional, 5-dimensional, and so on, right? So unlike your list, which can hold out data of any type, NumPy are recommended to use homogeneous elements, in the sense elements of same type, which is typically a number, right? And also NumPy provides its own data type. So there is a int 16, int 32, int 64. I think int 8 is also there, which is like short, byte, long, int, and that sort of data type for numerical data representation. Okay. And another thing about NumPy is you have to tell what is the size of the array in advance. So in that sense, NumPy brings back the capability of languages like C in Python as an add-on. In the sense, like by default, Python doesn't provide that, but NumPy restricts you to declare your array dimension or a shape before, and so that NumPy can allocate memories and then like manage the memory efficiently. Okay, so NumPy is all about single multi-dimensional numbers, and then you do some process with it, as simple as adding, subtracting, all the way then matrix multiplication, transformations, applying some linear, exponential, whatever functions that you want to apply on a given set of data, right? So here are some of the examples. So you simply call the so the traditional or the very recommended way of importing NumPy is you import NumPy as NP, right? So it's something recommended. So you can just say NumPy, then instead of np.array, you have to say numpy.array, and then you pass a list. So once a NumPy array is created, so you can get a lot of information about that. So there is a type, what data type the variable is. Default, if we don't pass anything when you create the array, and then what is the dimension, right? Like X, Y, and so on. Size, how many elements are there? Shape, number of elements in each dimension, and then the data type, and then the item size of each element. Total size of the array also you can see, size of each element, and then you can actually get the data also. So this is a single dimensional array. And then if you look at here, so I have 1, 2, 3. What I created is called the NumPy ND array. It's a one-dimensional array of 3 elements, and the shape is, it has only one dimension, so the shape is only 3 elements. Data type is int 64. So 64-bit integer is, it takes 8 bytes. So each element takes 8 bytes, and the data is available in this location. Okay, so it is in the memory. So you can also get the data by reading it separately, right? And now we created a 2-dimensional array, right? So what you do is you create one list, comma another list, and then put that in a square bracket, right? So you can go for any level of nesting. So that's how you create 2-dimensional, 3-dimensional, and so on. Like how many ever dimension you have, that many outer pair of brackets will be there. And here I'm saying I want a data type of 16-bit integer. So that means I'm cutting down the item size from 8 bytes to 2 bytes explicitly. If I know that my value is not going to be more than 32,767, I can explicitly do this. Same thing we are giving, right? So here, this is the data and same ND array. So we have dimension is 2, right? So it's a 2-dimensional array. I have 6 elements. So it's a 2 by 3, right? So 2 rows and 3 columns. Data type is integer. Now the item size has become 2 bytes, right? And then I also added the D type to get what is the data type, and then D type dot name, whatever it is, right? And then we can also look at the who to get some information about like a report about the array itself. So it says in this session I have created 2 arrays. One is 3 element single dimension. The other one is 2 by 3. 2 rows and 3 columns. The first one take 24 bytes and the second one take 12 bytes, and then the data type and so on. So this is for all the np.who is something that will give you whatever arrays you have created. So especially if you're running this on a Python shell, maybe you see that your system is going slow, and then so if you look at it, then like you can get the list of arrays if you want. If you think that some of these things are no longer used, so you can simply say del then that variable so that some memory gets freed up, right? And so here there are some additional information that is available, and I'm not going to go through everything individually, right? So we create like some random values, right? And then we are going to add. So it's basically like so creating a list of random values, and then we are going to whenever you say append, so it recalculates, right? And then you simply use some of the functions that is provided, and then apply that function to each and every element, like the map function, right? So you can take a look at it, okay? And then there are some results available. But if you look here, so I just want to show you how many elements, like functions, methods, classes that are available. Okay, so that anything that starts with uppercase can be a class or a constant or a error, right? So around 48, so you have 46, you have some of those, and then you have underscore or double underscore specified some of those variables. So from 69, so you have several methods that are supported. So 69 to 624, almost like 500 and 550 plus methods are available that will talk about various different data types. So if you look at here, uShort is unsigned short. So you can actually restrict your data type to signed and unsigned, short, long, byte, and int. So like integers of several size, and then single precision decimal, double precision decimal, and so on, right? And then there are a lot of things that are available. Okay, so again, so this is not something that we are using in our this thing right away, but something under the hood, right? The second thing is Pandas. So if you want to know what Pandas is, like I just only put few information, but the Pandas documentation has a 10 minutes to Pandas. Okay, so here, so there are some of those things that you can simply take it and then try it out, right? What are the statistics that are available and all those things, right? Grouping. So if you want to know more, even the plotting, so this might be your, so you go for pandas pydata.org, or you can put a 10-minute tutorial to pandas, right? So this is a place you might want to start with, even though what I am showing is something of an awareness what you can do, right? So now, so what Pandas, right? So Pandas is a data analysis and manipulation model, whereas Numpy gives you capability to create very memory optimized n-dimensional numeric array. Pandas can take data, and then you can do a lot of analysis by loading the data into a Pandas internal format, which is called a data frame, where you can manipulate, you can add missing values and all those things, right? So it uses a table-like structure, which is table. When we talk about table, it's a two-dimensional structure that contains rows and columns. Okay. So the official name for a table-like structure in Pandas is called data frame. Okay. Even the Pandas means it's an abbreviation for something, right? So I forgot what it is. Data analysis or data set analysis or something like that, right? Python. something, right? So a two-dimensional data structure of rows and columns. So in this case, it can store a different data types, right? So it can store strings, it can store numbers, it can store booleans. And each of these data types will have default missing values. So if you don't pass a value, when you create a data frame, it will get automatically assigned, right? So it's like if you want to know an equivalent type that you might have already seen, a simple Excel spreadsheet where you might have had some data. That's something that we all might have done at one point or another. Or you can think about a table in RDBMS where you use SQL to extract. In our language, so we call it as data.frame. And then in SAS, so if you come from mainframe background or if your company has used SAS, so it is called a SAS data set. Okay. So what these different things have common is you can see the data, you can query it, and these also store some metadata that is under the hood. You might not be able to see it unless you explicitly ask about it, like size, number of elements, number of rows, number of columns, and all those things are kept up to date, right? So these data frames or tables or whatever it is, that is the thing, right? So it is available for optimization. Okay, so this is what Pandas is all about. Okay, now let's see how we can create a two-dimensional structure. So we import Pandas, and then the alias that is used is PD, right? So we call the data frames class. Okay, so we create an instance. So if you look at it, data is dcaps, and then I'm passing a dictionary, a list of names, a list of scores, and the grade, which is supposedly same number of elements in each list. So what we are doing is we are simply calling this Pandas automatically takes this name, score, and grade as 3 columns, and then it puts the value. Once the data is loaded, you might have hundreds and thousands of rows and columns. So if you want to simply look at what you have loaded, we can use the scores. So scores is an object of type data frame, right? So you can use the head method or a tail method to get some information about the loaded data, right? The head and tail are equivalent to the head and tail commands on the Unix. So if you don't give anything, it will give you 5 rows. So if you give a number, it will give you that many number of rows. We only loaded a 3x4 matrix. Okay. So by default, it also assign an index number for each column, each row. So 0, 1, and 2. You can actually add some conditions to remove it. If you have key information like student ID or something like that, so you can make that as an index instead of Pandas supply default index. So you can also get information about one or more columns. It is simply like the way you take it from a list. So scores is a data frame. You give a column name. It will give you the index by default and then the values of that column name. So now, so this one-dimensional column, right? So if you create a data frame with just only one dimension, or if you are using like this in any computation, so this is called the series. Okay, there are two types in Pandas. One is series, which is like a single column. Other one is a data frame, which is a multi-column, which is two-dimensional data, right? So you can create a series also. So let's say I am keeping the attendance of several students, right? So I'm just randomly creating a random choice of present and absent for 20 people. And then the column, the series name is attendance, like the column name, right? And so it simply created 20 elements with A and P, right? And so once you have the data available, so you can do a single variable or a multi-variable statistics. So let's take our original element. So I have score here, 475, 592, 390 and all. So I want to take an average of scores, right? A very simple one. You simply call the data frame with on which column you want to do the average, and then you call the mean method. So if you want to know min, max and those kind of things, you can do that as well. So now I want to do multiple statistics on that row. I want to find out the maximum, minimum, average, number of elements, and then I think the sum is also there, I guess. Okay, not sum. Add np.add. Okay, we can figure that out later. Oh, okay. I think I need to run this again since I opened this. Okay, and then we will go here and then we will run this. Okay, so there is a minimum value, maximum value, count, average, and everything, right? So this is something that you can use it further, but if you really want to get this as an information, so you can simply say scores the data frame name dot describe. Okay, so what this will do is, so here we have only one value. Okay, so if I have multi values, right? Let me do one more thing. Attendance. Okay, so we are going to give attendance in days for these 4 people. So I will just say 80, 89, 75, 77, and then 45, something like this, right? So we have a different one more column. So let's say if I run describe, so every numerical column that is present, it is going to give you minimum, maximum, standard deviation, 25%, 50%, 75% quartiles, max, and all these values, right? So basically the describe, mean, these things, like as soon as you load the data, you want to get some quick information. What is the data I'm dealing with, right? So the describe is a pretty good way to find out information about the numerical columns. Right, and then so since this is a table, so you all might be familiar with the concept called index or keys, right? Something that can be used to access a group of data very effectively. So you can get this. So if you look at it, we didn't create any index, so it gave a default index of 0, 1, 2, 1, 3. So that's the index that is available. Columns, I think if I run this again, so I have name, score, attendance, and grade, right? So if I want to sort the data frame, I can use by index. I can say sort descending, which is nothing but ascending false means I want to do a reverse sort. I can also do a sort by the score, which is like minimum to maximum. Here also I think we can do the as ascending to false. So higher to lower, right? And this is a very quick way of transforming. You convert the rows into columns and columns into rows. So name, grade. So this will help you. So if you want to create some quick reports. Okay. So this is something I have taken it from like one of the videos in YouTube. So the entire thing is a copy paste of whatever somebody has done. Okay, so let's take a quick look at how we can download. So earlier we created a series and data frame using hard-coded data, right? So there is a file online. It has information about alcohol consumption by country, how many servings the country might have spent, something like that, right? So it has two categorical data, the country name and the continent name. And then it has numerical data about beer serving, wine, spirit, and total liters of pure alcohol, right? So we just loaded it and then we saw head, right? And then we are going to look at, call the count function on the data frame. It is going to tell you in each column how many elements are there. Okay, so this is 193. But sometimes if we have missing data, right? For example, like let's say in Afghanistan, so instead of 0, we didn't have anything on the original CSV file. 0 is explicitly given, right? Then that will be a missing value. So some of the values might be missing. So the mean we have seen. So here is another classical thing. This is what we will be using. So what I'm saying is, in this data frame, group by continent, and then give me a mean of beer serving. So Asia, Africa, and each continent, what is the average beer serving that happened, right? So apparently Asia is very less, Europe is high, and then North America next level, and South America, and so on, right? So this is how, like one line. So if you look at it, so this is where the beauty of Pandas comes into picture. So if you look at the query, I wrote select. So if you want to do this one, right? So what we will be doing is select continent, comma, AVG of beer serving from the table group by continent. And this is what we might have done, right? And then order by continent also. So this long it takes, right? So in order to do this, let's say my table name is DF, right? So this is the Pandas, and then we will say select continent. I think AVG is the function name, I guess, right? So that's the equivalent, right? So you see how succinct that one line is compared to the query. And then if you're talking about our own logic, so declare a dictionary and then do all those, right? You need to set up before you get it. So this is 4 lines, that is 1 line, that might be 20 lines, right? And then, so this is another thing, right? So this one is select average beer servings from DF where continent is Asia. So that is the query that you might be doing. Okay, so one of the way, if you are not coming from R or SAS or any other database background, if you know already database, one of the way to understand Pandas is to at least initially to try to get the equivalent SQL, so that how Pandas is doing the syntax, right? So here you go. So we do a group by continent, and then on that I want aggregation to be done on the beer servings, and then I want all these things. So now 1 line, so we got each continent, what is the minimum, maximum, average, and count of beer servings, right? So if I simply say without that variable that has a numerical value, right? So here we saw beer serving. So here we didn't see anything. So Pandas intuitively go and look at all the columns that are numeric, and then it applies the mean for every candidate. Okay. So now the highlights. So you have this value, and then you simply use this matplotlib inline, run the query, right? This one, and then simply dot on that. You just say plot, a very basic plot, kind equal to bar. Okay. So if we are using a pie chart or something, then you might have to add something, right? So if you look here, so Africa, Asia, Europe, North America, Oceania, and South America, every type of servings. So you got a very quick visual representation of this particular data, right? So that's a quick introduction to Pandas. Okay. And then if you want to do a group by two things, like the way we are going to do, like we are going to do it by district code and performance level. So here, continent and country. So each continent, each country, and then so it applied the mean for every country, every numeric columns, right? So again, I have seen a lot of tutorial videos, paid or free. So at least 7-8 hours have been dedicated to talk about various features that is available in Pandas. Okay, what I did is a 20-minute quick introduction on both Pandas and Numpy, just to appreciate how easy it is, right? So now let's go and look at the case study. So this is, we imported the Pandas, we imported a Numpy. So we have the file name, and then I have this district code. Again, this has been put it in each and everything because I just want this to be a standalone one, right? So here what we are doing, we don't have header. So I'm just creating, first thing is like we are creating a data frame based on the district information. So we put district code and key, so that like it is available, so you can join, you can do a join, right? So this is one data frame, which is a lookup. It contains the district code and then the district name. And since our CSV, if your CSV has header, Pandas can take the column names if you say header equal to true, right? So here it doesn't have. So I'm just creating a CSV header, right? So what is the input CSV file contains? That's one variable. And the second variable, I'm just saying the fields I want is 3 fields: district code, performance level, and district. Okay, so whenever we are downloading from the CSV, we are going to download only certain fields. So we use the read CSV method, and then we give the file name, and then we say what are the field names and what are the columns that I am going to use. And then I am also going to say index column equal to 0. So that means the 0, 1, 2, 3 won't be given. Okay, so this line, right, the combination of this line defines what my input fields are, since the header is not available, and what I am going to download. And then it calls the read CSV method. It creates a data frame, right? Now, again, this is what I was talking about. This thing, right? This might be, we might be able to do it while loading itself. So what I'm doing is I'm creating a new data frame, and then that will contain all the records other than that only when the do not report is n. So this is filtering. Okay, I didn't find another way to do it while importing it. So there should be some ways, right? And then what we are going to do is we are going to use this district lookup data frame and then this data frame. So both contains the district code as a key, right? I'm just going to merge these two data frames so that I will have the district name as a part of my data frame, right? So step 1, download. Step 1, create a lookup for district names. Step 2, download only the required fields from the CSV. Step 3, merge those so that you have district name as a part of your data frame. And then finally, what I'm going to do is I'm creating the summary. From this data frame, I am grouping by district name and performance level. And then what I want is count. Each performance level, what I want is a count, right? So this will be the group by. So this part will be like this thing, right? So you have a broader key and then sub keys and then the counts. But what we want is this kind of report that we saw in the other cases, right? This one, right? So in that, we are using the pivot table concept like Excel. So what we are saying is pivot the data, right? I have an ag states, pivot the ag states, you know, like okay, so the I forgot why I have put this. Probably I can check. So the columns is performance level. So each performance level has to go in its own column. My row or index is key, and then add function is I say sum. Okay, so here it's the sum is not needed. Okay, because each of these combination of district and then the performance level is going to have the one value, but that is how you can bring, right? So you have to do some sort of add function. So it is going to give this, and then fill values equal to 0. So in case if some value is missing, so we can give a 0, right? So if you look at it, there is no conditions, nothing, right? So it's basically these 4 lines, or like, you know, these 5 lines that created an aggregation for yourself, which is something even readable, right? But only thing is this 5 lines even can be reduced to 3 lines. So if I know, or if I do some pre-data cleaning where like I add the district names in advance to the CSV file or something like that, right? But so all it took is 5 lines to create a report, right? And here probably some 30 lines, and then here probably oh, this is the data. Okay, so another 35 lines. Okay, so if you look at the line of code, you know, the pandas still fare better. Okay, so now is it good? So if you look at the, again, when you talk about something, whether it is good, better, so again it depends on good for what, right? So yeah, obviously if you look at the line of code, it is good. You don't have conditions, so all those group by filtering, everything is internal. So you write declarative statements in pandas, which is again good. So right, every coin has 2 faces, right? So obviously there should be something that is not so good. Since you are delegating all these conditions, filtering, rearranging everything to pandas, so pandas might take a bit of a memory and processing cycles, which much more than your typical database application or in-house file operations, right? And the second thing is, depends on how big of the data. In scalability wise, pandas might work better. So you might need a bigger machine. So with the advent of cloud these days, it is not a problem. Even if you're not a corporate, so let's say, so you have some huge volume of data, right? Which you anticipate it is going to run, 24 hours maximum. But that is going to give you a very concise result of how certain shares are going to perform, or like, you're going to a casino, what is the best way to play blackjack or roulette or whatever it is, right? And some forecasting. So you can get the powerful machine in AWS for $4 an hour, which contains 64 core processor, around 2 TB RAM, and how much ever hard disk you want to put. So if you're running for 24 hours, so probably 24 into 496. If you are willing to spend $100 or $150, what it would originally take a supercomputer for someone to buy, which is only corporations can do, as an individual with some 10,000 to spend, if you are so sure about your data, and then the modeling or like the analysis that you have done with your smaller data set, right? 15,000 will give you a wealth of information, right? That means you don't have to invest money, even as an individual, in buying hardware. Probably that might cost you probably like some 30-40 lakhs, right? So you don't need it. So 15,000, it is all available for you. You can destroy the machine, store the results, and be happy, right? So in terms of scale, in terms of variety of analysis, Pandas and Numpy will be very good, right? And it's not the only thing. There are other modules that are available. So as a beginner level, I have taken up this one, right? So that brings the conclusion